batches. So seats are filling up. You need to make that decision fast. So you need to be really, really fast as we go along, as we do this. I was just hearing myself a bit distracted. All right. So without further ado, I start by introducing myself. I'm Dr. Siddharth Pandey. I head the Center of Excellence in Astrobiology at Amity University, Mumbai. My background is aerospace engineering, and I made my journey as I studied in India, in Europe, worked at NASA in the US, and completed my research studies in Australia in aerospace engineering. And there I met an awesome group of people who were exploring alien-like terrains in different parts of our planet. And I decided that this is something I really wanted to contribute towards. And we started our first expedition planning in 2015 for India. And that's where Jonathan Clark, Annlise, Kunal, and a few others, we met for the first time. It's been, 7 years? It seems unreal that it has been so long. And since then, we have been working. We have committed ourselves to advocating Ladakh as a terrain that can support space exploration. It is a site that can be used to study our planet and understand what are the changes our planet is going through, the different people who live and work in these lands, and working closely with them, and also enable students to get an opportunity to train to become space scientists and earth scientists, and also individuals who are curious about the natural environment, who want to get a transition, who want to learn more. And they are our explorers. And we have several explorers who will be joining us this year as well. In fact, we just ended our meeting, our first meeting with the confirmed participants for this year. And we had an amazing time interacting with participants from around the world who will be joining us in Ladakh this year. So that's my introduction and the program's introduction. And I'd like, if one by one, people can perhaps introduce themselves. Pavithra, I know that you're having some patchy internet today. So would you like to switch on your video cam and give us a quick introduction?
Yes, sure. Can you see me?
Yes, now we can.
Yes, okay. So I am Pavithra Shrikha. I am actually an assistant professor at the Center of Excellence in Astrobiology at Amity University, Mumbai as well. My background is actually very interdisciplinary. I started as a physics major, doing a lot of astronomy and astrophysics, and then moved to planetary geophysics. And then I also have some experience in environmental sciences and meteorology and things like that. So I've kind of juggled quite a few sciences together. So I'm a huge supporter of interdisciplinary science, but my main core research area comes in planetary geophysics. My PhD was at Virginia Tech, and I did research on a NASA project, mostly on understanding volcanism on the surface of Mars. But I moved over from volcanism on the surface of Mars to understanding hydrothermal systems and using Mars analogs on Earth as well. So a lot of my work is involved in impact crater systems and trying to understand the hydrothermal systems, so serpentinization, brine, and actually its implications to astrobiology. So I'm really excited to be a part of this, and I really hope a lot can be learned from this, especially with Mars being sort of the location to be at these days. So the future, especially going in that direction. I specifically at Ladakh, I am more interested with the hot springs and what kind of hydrothermal systems are there and the tectonic plate activities going on. So that's about it from me.
Thanks, Pavithra. And while we have your internet working fine, I think you can definitely stay on in the call.
Sure.
And let's move on to maybe John, our scientific coordinator.
Yeah. It sounds very pretentious, doesn't it? Look, most of you know me, but just as a reminder, I've had a career in geology, working on 5 continents and 3 oceans. I was in Ladakh in 2016, amazing time. Thank you, Siddharth. In more recent times, I've been working on Mars spacesuit design for an aerospace company. So interesting change in career. In Ladakh, I would be, other than sort of helping in the coordination of the general science program, I'd also like to supervise students in doing geological mapping, geomorphological mapping, and surface material mapping. And Pavithra, I've just sent you an email about that, because they'll obviously will need to compile mapping sheets. I mean, it's very low tech, but it's a really good way, as you know, Pavithra, to get students to start actually interacting with rocks and surface materials and landforms. And I think it would be very, very helpful and very useful for the project, because I think we can focus looking at mapping the site where we want to build a station. So that's really all I've got to say at the moment, unless there's any questions.
Thanks, John. We'll keep moving through the introductions. Annlise?
Well, hi, everybody. I'm Annlise Beattie, and I'm from Mars Society Australia. So a lot of my work in the last decade has been in extreme environments, from the deepest, darkest, quietest mines in the world to the high glacial valleys of Ladakh. I was there in 2016 as well. Thank you so much, Gunnar and Sid. It's a great trip, and I'm really looking forward to going back. So my role on this trip is to try and situate art as an alternative form of knowledge. So the techniques and processes and strategies of art, and try and think about how I can situate those amongst other disciplines. So using art as a methodology to think about how we all might live together in the future, and exploring different ways of working and finding new ways to kind of build communities and share meaning through art making. So I'm really, really excited about going to Ladakh. I can't wait. I wish we were going next week. And I guess that's about it for me. Thanks, Siddharth.
Thank you. Anita, ma'am?
Yes. Hello, everyone. I am Dr. Anita Jobby, and I'm working as an assistant professor in the Amity Institute of Biotechnology since the last 7 years. I have been associated with the Center of Excellence in Astrobiology since the last 3 years through Dr. Siddharth. So that was my first experience into the field of astrobiology. I was actually trying to integrate how my subject, so I'm a microbiologist, and I was trying to integrate how my subject can be integrated into the field of astrobiology. And it all started with our initial payload development and understanding how microbes can survive in the microgravity. And thereafter, last year, we had some sample explorations from Ladakh, which has led on to quite a few good, interesting projects. And this year, it would be my first field trip to Ladakh. So I am equally excited as all of y'all are. And apart from that, I am very much interested in creating microbiology literacy among the non-scientific population. So that would be one of the aspects that I would definitely like to cover in this trip, wherein we initially have a first group, which is quite diverse. So it's actually going to be a very interesting one. So we'll be looking onto the various microbial sites and locations, and the possibility of existence of life and the limits to which it extends. So thank you. Looking forward to meeting all of you all.
Thanks a lot, Rita, ma'am. So there's several other scientists who are not on this call, and we'll hope to have more interactive sessions in the next coming weeks with some of them. In fact, Dr. Michael Macy, who has confirmed his participation, is currently in South America doing field work. So he's most likely going to be back into range of contact within the next week or so, and we'll definitely try and find a way to have him join us for the next episode. But I think this call is mainly to give those of you who are still on the fence on whether you should participate or not an idea of who are the kind of individuals you will be interacting with when you're in Ladakh. And several people find this program interesting for different reasons, right? For those of you who are students who already know about astrobiology and are just unsure as to how do you find a career into this. So maybe I can ask that question to all of you right now. So how does one become an astrobiologist, and how can this program be of interest? Would John, would you like to take that question? How does one become an astrobiologist?
Yes, there are many paths to being an astrobiologist because astrobiology is a discipline that synthesizes many different disciplines. And so, for example, some people like Siddharth, yourself, Siddharth, have come to it from an engineering background, from the point of view of designing tools, be they instruments or sampling tools or even entire spacecraft to study environments on Earth or on other planets that are of interest to studying the history of life in the universe. Other people come from a biological point of view. They are interested in the habitability of Mars and other planets. Or they are interested in extreme bacteria on Earth, or how life is adapted to extreme temperatures or acidity or low pressures, be it as it may, on Earth. And then they apply that to the search for life elsewhere, search for habitability elsewhere. I'm a geologist. I'm interested in planetary exploration. And so I bring geology to the table. Other people may come from other interests, the cultural interest, the sociological interest, the outreach or education interest of spreading the significance of astrobiology to the wider community. So there are many paths into this, and I think almost every discipline that people have can contribute in some way.
Thanks a lot, John. Annlise, would you like to add something to that from your perspective?
Yeah, I think it's going to take all kinds of people to go to Mars, and some people will be science generalists like me. So astrobiology, I remember when we were in Ladakh, the biochemists would be going, it's the chemistry, and the geologists would be going, no, it's the geology. So there's always that question, where does life begin? And I think astrobiology synthesizes a whole lot of disciplines and helps us understand the big picture of the universe. So it's a new discipline, probably just a couple of decades old. Would that be right, Sid? Just a couple of decades? And it's a discipline that everybody can, everyone can participate in. So from my point of view, as an artist, I felt astrobiology is an inclusive kind of discipline that allows me to find a place for myself to try something out. And yeah, that's what I'd say about that.
What would be the most challenging experience, Annlise, that you faced on a previous analog mission or expedition?
Oh, I think so. I was part of Mars 160 with John, and I spent 3 months in Utah in a space simulation where we ate dehydrated food, and we only went outside with a spacesuit. That was a challenging experience. That was rigorous. I think, get fit if you're coming to Ladakh. That's all I can say. I remember the ataxia and the, as an artist, I'm really interested in sensory deprivation, how our senses respond to extreme environments and what that means for us. And so, the greatest challenges, I think, is feeling the body in those extreme environments, right down deep 1.5 kilometres in Bulbi Mine under the North Sea, where there's no lights. It's a dark mine. The body, your body feels very strange. Your vision blurs. You can feel your organs floating. So I guess the biggest challenges for me are the challenges of the body in space, how the human person moves through space. And, yeah, I'd say that's what it would be. So I'm always really interested in how to draw in those circumstances. I'd probably draw more rocks in a spacesuit than anyone in the world.
And that's really interesting that you find so much of depth and knowledge, artistic knowledge, in places that wouldn't be the first choices for so many people, which are not conventionally vibrant and lush and colorful. Many a times these places are dark, they are gray, or just like monotonous in terms of how they are, and also in terms of the people and the life that we find there. But you're able to connect with all of that and still be able to appreciate and find value in it, which I think is amazing. And very few people are able to do that. So your experience is working in the mine. Tell us a bit about how in those kind of circumstances you were able to connect that with space, or working.
I guess my role in Bulbi Mine, I've been there a couple of times. My role was to think about how art might evolve and survive in places that are not conducive to art making, like a mine, a dark, quiet mine that is about routine and rigor. And really, art drops off the list, when, survival is the most important thing. And, the routine and the discipline and the health and safety risks of being in a dark, quiet salt mine like Bulbi, it's extraordinary. So my experience is there. So what I would do in that what I did in that very first circumstance, I was there with 35 space scientists, and I gave myself the role as field artist. So I try to poach, I try to get art to poach into another discipline so that I can situate myself and give myself a role and explore what art might be in that context. So the second time I went back to Bulbi, so field drawing, I did a lot of field drawing the samples, drawing in the dark, actually really drawing in the dark, just couldn't see anything. So the second time I went back there, I went back with my partner Cliff Dolliver, and we were allowed to spend more time in the tunnels of the mine. And we did a lot of drawing of that point of contact where human life disappears, where you look down into that black hole and the electric cables go down into that hole, and that after that, like, there's just nothing. So that was, 40 degrees, even the rocks were like 40 degrees. So that was, again, that was a really interesting, challenging time for me. It helps you find other ways to work and helps you understand what it might be like in deep, vast space as a tiny person in a small, contained environment in an enormous universe. That was a bit of a rambly answer there, Sid, but I hope you got the general idea of that.
We will try to feed off your energies and keep the conversations going. But thank you so much. That was a very descriptive answer.
Yeah.
Right. So let's keep rolling. We have a few questions, but before that, I'd also like to talk a bit about Dr. Anita and Pavithra, who are not traditionally field scientists. In fact, both of them come from a non-field background. Of course, Pavithra mentioned she has some field experience, but from a research background perspective. Dr. Anita comes from a lab background where she's been working in wet lab environments. And Pavithra comes from a theoretical numerical modeling background. So maybe one by one, both of you could just briefly tell us your motivations, because there's a lot of scientists who don't value working in the field. They think it's a waste of time. They think, they were better off doing their own research in their own labs with their computers or with their own, benches, lab benches. So tell us a bit about what has motivated you to get into the field. Either of you, Renita, if you want, you can start, or Pavithra, whoever.
Yes.
Yeah.
Okay. So, as Siddharth rightly said, I come from a basic lab background, but definitely during my PhD, I had to collect samples, that also plant samples, which had these root nodules that were there. And that's, I think, where I actually started my first small bit of field explorations. So it was like there were different areas that we actually explored. But then after that, it was a completely lab work based aspect. So I always used to wonder, like, it was the normal environment that we actually had in, and how much would it differ when we are considering high altitude environment and actually working on the field on these high altitude environments. And a little bit about the extremophilic nature of these microorganisms that were actually there. I used to think, okay, then it is quite possible that, we have hot springs, we have these salty environments that are there. There are many type of publications that are coming in related to them also. But do we actually have that kind of a diversity that exists? So though we say that, many of them are, related to the lab aspect, but it's important to understand that in the field also, to understand what kind of approach do you need to do in the collection aspect, because many a times it happens that we may miss out some small attributes when we are actually collecting those samples, which would be a field mistake that we actually make on the field. So until and unless you actually go onto field and try to do that yourself, try to also get experiences from the people who have already visited there, it is quite possible, and I would definitely say at least 70% of your errors that you make on the lab starts from the errors that you have made in the field itself. So until and unless you go there, you won't be able to give out that same experience to the people or to the students with whom you are planning to do that work ahead. So that is also one reason, since we already had some samples which we had brought. And when we actually brought them to the lab, I would actually talk to my students and then say, okay, I think we should have done it this way. I think we should have, collected them this way, or we should have stored them this way. So that is also one motivation that I had to go on to the field, so that I will learn myself first how it is to be done. And since we already have many experienced people who are also joining us, so I would definitely like to learn along with them. And also with the help of many participants who are coming from the diverse environment, this is also going to be a trip wherein I will learn how is it that I can, support in the form of the knowledge that I can provide, not just through the scientific publications that we write, but definitely through a normal common man's language that we can use to communicate our work and the field studies to all of you all.
Thank you so much. And I should add that you did a splendid job mentoring some of the last year's participants who came to our campus after the end of the 2021 season and trained in your lab to work with some of the samples. So thank you so much for that. Pavithra, over to you for a quick motivation.
Yes, absolutely. So one of the reasons I am very interested in Ladakh and doing fieldwork is because I come from a computational modeling background. So this is going to sound like a very cliche answer, but the thing is, when we were trying to publish our paper, there was quite a lot of, when you are a modeler, there's a lot of justification you need to provide as to why you're getting certain results. And especially with Mars analog studies, it always helps to kind of compare what you have out there instead of just, kind of just modeling a bunch of stuff all the time. So one of the reasons I was really interested in fieldwork, and one of the reasons of also coming from a computational background, is I feel like you should be able to justify whatever research you're doing and whatever you're trying to imply, especially if you're using Mars and you're kind of trying to do analog studies, whether it's Enceladus, Europa, Mars, whatever kind of planet it is. And I kind of really missed out on that opportunity because I come from, as you mentioned, from a theoretical background. So a lot of my work was on geophysics or planetary geophysics. So I kind of missed out. And I think it would provide a lot of input and also make sure that the science makes sense, because maybe other modelers can agree with me. When you're in computational modeling, you can run 10 billion models and collect so much gigabyte of data that you just don't know what to do with it. And at some point, you just kind of like, just trying to justify whatever you're trying to do. So I think a lot of my work comes from that. And also, as Annlise rightly mentioned, astrobiology is kind of an upcoming field. And it's something that's being applied to not just Mars, but even to other planetary bodies, to other icy satellites as well, and so on. So I think it would be really useful, especially, with the future heading in that direction. So I think it would be amazing if you could model something and justify it with the hydrothermal systems, in my case, for example, and be able to apply that. So especially in the case of Mars, maybe understand the system during the Noachian period, which was like really long back, and look for life.
Thank you so much. And, we encourage more and more people to experience the field, both from a researcher's perspective and a student's perspective. So now that you've all heard from our scientists, it's time to take some questions. So while we've all been chatting, there's been a chat box that's been filling up. And let me just go through the questions real quick. The first question is from Anurup. How will the program differ from last year's program? So Kunal, do you want to give us a very quick answer on that?
Hi Anurup. The program is different this year because we have added 2 more destinations, and we are spending more time in Ladakh. Like last year we did only Sabu and Sokar. This year we are doing Sabu, Sokar, Somururi and Hanle, which is a dark sky reserve, and we'll be spending a night there. So the program has already changed from 6 nights to 8 nights now. And we have international scientists coming in and joining us this year. And there are a lot of other changes which you will be finding up. Please stay tuned to our pages on social media. And we'll be posting all other things as soon as possible.
Thank you. So Nilesh asks, are there any master's course in astrobiology in any other countries? Or should I pursue masters in a field of my interest, which is evolutionary biology, and then get into a research in astrobiology? Would someone like to give a quick answer to that? That's a career question. John, would you like to take that one? It's not your field, but a general question on getting into astrobiology. Should they pursue a master's in evolutionary biology and then get into astrobiology, or go for a master's specifically in astrobiology? Sorry to put you in a bit of a spot there.
I think if you're registered in astrobiology, it is far better to get to do a master's in a relevant discipline that has an astrobiology focus than it would be to do a master's in astrobiology, which would probably be coursework. It'd be far better to have a master's in microbiology or instrument or that was related to astrobiology, or say instrument design related to astrobiology, or anything like that, or looking at ancient life on Earth or the geology of Mars. And applying that to astrobiological questions, I think you'd be far more likely to get further employment in the field than if you just did a very general master's in astrobiology. But that's just my own feeling. That may change, of course, over time as astrobiology becomes a growing field.
Thanks, John. I think I'll add on to that one should definitely look at the coursework that is being offered in the program, and also look at what kind of researchers are associated with that program. and what research opportunities are offered for your master's research project. So rather than looking at the title of the course, look at the content and look at what opportunities are opened up for you once you go through the program as well. All right, so Bharti asks, is the terrain challenging, and could you tell us a little bit about AMS? So AMS is acute mountain sickness, and this is something that affects you if you have not prepared yourself well enough or are extremely exposed to a high altitude region where your body has not gotten enough amount of time to acclimatize or get used to it. So normally when we go to high altitude regions, we spend 24 hours, say for example, if you're going up by 300 or 500 meters, you're supposed to spend 24 hours before you climb further. You might be able to spend a short duration and then return back. So when on this expedition, when we will be landing in Leh, we will be arriving at 3,500 meters above sea level. So there is mandatory rest that has been directed to all the participants. We'll be spending 3 nights in Leh. That gives us sufficient amount of time for the body to get used to it. And then we'll be moving on to some of the higher altitude sites, but only after spending enough time resting before we move forward. So you can read up about it. It's a very serious thing. It is not dependent on age or a person's physical fitness, but it's something that can affect even people who are very experienced expeditioners and adventurers and people like that as well. So you just have to be very mindful and you have to prepare for it, and one can easily overcome it.
Yeah, I agree, Siddharth. My experience, I was quite unwell in Leh for the first 24 hours, and I remember our medic Padma saying to me, Annalise, you don't take tablets, you rest and you adjust and see how your body manages it. And I bounced back after 24 hours. I was absolutely fine. So it is a serious thing, and it is something you have to get used to. It's something you should be prepared for. Think about, what it might be to be in such a high place. But your altitude tablets won't fix it. That's what I'm saying.
Yes. Thank you, Annalise. So we have sufficient.
They won't fix it, but they do help.
They do help. Mm.
Yeah.
Yes. So for the participants,
and
sorry, John, go ahead.
Yeah, I just to give people an impression of how high we're going. The lowest place we'll be going is Leh, when we fly in, which is at 3,500 meters. So when you fly in, airliners are pressurized to 2,400 meters. So when the plane lands, they have to depressurize the plane to let you out. So, we're going a long way up in the sky. And some of the highest places we're going, the air pressure will be only a little bit over half what it is at sea level. I mean, some of the high passes will be driving over 5,000 meters. So, as we say in Australia, when you get to Leh, don't go at things like a bull at a gate, right? Take it easy. Sleep, take your pills, drink lots and lots and lots of water, and, be kind to yourself.
I'm hoping we can get an experiment together that monitors the oxygen levels in our blood. I remember last time we went, Siddharth, when we had those little things we put on our fingers, and every hour we'd be checking to see how much oxygen we had in our blood.
I'll bring one.
We'll have a bunch of those. In fact, due to COVID, all of us have bought one for our houses anyways. So we'll definitely be monitoring, and there'll be constant supervision and monitoring of every person. And
vitals checking will be done
just
every day.
Again, to illustrate that, it's just to illustrate that for people. In normally, people, wherever you are in Delhi or Mumbai or wherever, your blood oxygen will be somewhere between 96 and 98%, unless you're sick. But when I arrived at Leh, it was 82%. Now, if you went into hospital in Delhi or Mumbai with a blood oxygen of 82%, you would be seriously ill. They'd treat you as if you had a major illness. And look, after 3 days, it was back up to 94%. But just as I said, be kind to yourself.
Yes. So we are not going to all be very athletic, Olympic champions there. But at the same time, because we will be spending a lot of time in the field, in the sun, walking around, having a busy schedule, we are not going to be tourists as well. So there is a certain amount of training and planning that the team will be undergoing, as has been happening since our first expedition 6 years back. And we continue to follow the same safety protocols and code of conduct while we're preparing for this trip. So it actually helps one become quite disciplined in terms of working in a team as well. You learn time management, you learn how to pack, you learn how to manage resources. There is so much one gets to learn as part of these expeditions, even outside of the scientific education and other things that you learn. So thanks everyone for your kind inputs on that. So we are running short on time. We'll just take a couple of more questions. So first question is, will analog astronaut missions be conducted with spacesuits in Ladakh? And I think John is the best person to talk about analog astronaut missions in Ladakh.
So what was the question? Could you just give that question again, please, Siddharth?
Yes. So will analog astronaut missions be conducted with spacesuits in Ladakh?
We certainly can do that. Whether we'll be using a simulator spacesuit there will depend on whether we can build one in time. But if not this year, then certainly I think next year. I've got the bits for one here in my office and in the garage, but it'll take a bit of work to pull that together. Siddharth, I'm not sure if you're going to be able to make one in Amity in time, but it's a very valuable tool in general for people who are interested in human exploration, because when you put on a simulated suit, even though it's just a costume, you become isolated from the environment. And Siddharth has done it, and Annlise has done it. It's a very different experience, and you have to work very differently to would if you're just walking around. And to do that at high altitude will be an interesting challenge. Just out of interest, in terms of real astronauts, when people go to Mars, they will probably be living and working in their habitat, in an environment, in a pressure regime similar to what we'll be having at SOCAR. Because the pressure will need to be lower than what it is here on Earth, so that people can rapidly decompress and go out into a spacesuit and work on the surface of Mars. So, that'll be an interesting challenge.
Just a word on the UV radiation, John, please, because we have to bring our sunblock, and UV is very high there. Could you just tell us?
Yes. Because the air is thin and is lacking in water vapor, there'll be more ultraviolet than at sea level, and there'll be more hard ultraviolet, which is the one that burns you. So people should wear long pants. People probably want to do that because it's cold anyway, but always wear long pants, always wear a long sleeve shirt, perhaps even you certainly wear sunscreen on your hands and on your face, a wide brimmed hat, or some kind of head covering, like people wear in the Middle East, will protect you against
sunglasses, that. Good sunglasses.
Sorry?
It's
and
sunglasses.
Yes, polarizing sunglasses. Not just tinted ones, but polarizing sunglasses that will cut down that glare. Otherwise, people will be getting headaches anyway from the altitude, and if you have a lot of glare, which you're working in all the day, and you get dehydrated, people can feel very, very sick very quickly. Bring a water. Make sure you've always got water with you, and keep drinking. Because it takes an hour or so. Once you've had a drink, it takes more than an hour for that water to be absorbed by your body. So if you wait till you're feeling thirsty before you drink, you are already behind. So you get up in the morning, the first thing you do is, drink a glass of water. Drink several. The humidity is very low. Last time I remember we had humidities of only 9%. So you'll be losing a water vapor as you breathe off your skin. You won't even if it's hot and you're sweating, you won't even know that you're sweating because it'll evaporate so fast. How's that?
Thank you, John. That's a great first.
Stephen has a question that if you're allowed to have a laptop and sky cameras means drones. If people are talking about drones being a military area, we are not allowed to fly drones in Ladakh region. Yes, you can get your still cameras or video cameras, but for drones, we need a specific permission from the military, army, and yes, you can bring your laptops along with you.
Yeah. And I think I'm not sure what a sky camera is, but any camera that they have that they would like to use that is pointed, say, for example, to the sky or something, they can definitely bring those and have those running. That's not at all an issue. And we'll take one last question from a...
Can I just have one comment on that, Siddharth? If people are bringing laptops or tablets, keep them inside a plastic bag when you're not using it because the dust will get into them.
Thank you, John. Yes, so that's definitely good advice. Dust is a serious concern. So there's a scientific question I think I thought I'll end with. So Nilesh has asked how the atmosphere in Ladakh resembles that of the early Martian atmosphere. So just kind of going back to the link between Ladakh and Mars. So would either John or Pavithra, one of you would like to answer that? John, you want to go?
Yep, I will. Early Mars, this is Mars that is more than 3.5 billion years ago, had a denser atmosphere than it is now. Probably very similar to what Ladakh has now. So the atmospheric pressure would be similar. Because we know there was more running water on the surface of Mars, and there were lakes. So we know the temperature was probably, it was cold like Ladakh, but at least some of the time it was above freezing. And of course, it would have been high ultraviolet, just like Ladakh. There is some evidence that early Mars had small amounts of oxygen. So the environment would have been somewhat oxidizing, again, like Ladakh, although I don't think Mars ever had 20% oxygen in the atmosphere or 21% oxygen in the atmosphere like we have it now. But certainly temperature, pressure, ultraviolet, and perhaps oxygen levels are comparable to some degree between Ladakh and the early Mars.
Thanks, John. Right. So that gives us the first teaser or, inside view of what is to come this year. As you can already see, we have people from varied backgrounds on our science team, and the participants also come from interesting backgrounds. We'll probably introduce some of them over the next few weeks to all of you. So with that, we conclude our first live session for ESEP 2022. If you haven't signed up, the seats are filling up fast. We encourage you to contact our team and lock in your place. And we look forward to interacting with you as we go along. So thank you and have a nice day ahead. Thanks, everyone.
Thank you.
Bye.
Thank you.
Bye. Thank you.
Bye.
Bye. Bye. Thank you.
For a few weeks.
Yes.
See you.
All right.